Let's look at short-run production. We're going to assume that there's only two factors to production, capital and labor. Moreover, we're going to assume that capital is fixed in the short run. So the only variable input in the short run is labor. We're going to fix capital at the level k bar. So the short run production function is f of L k bar. So if you use L units of labor in the short run, which you could vary, you can pick any L you'd like, but as a function of the L you choose, the output is going to be f of L and the fixed k bar. So that's the quantity that you're going to be able to produce. We're going to call this quantity Q that you produce when you use L units of labor the total product of labor. This is going to allow us to define the notion of a marginal product. So the total quantity of output that you produce when you use L units of labor is f of L k bar. So what's the marginal output for every additional unit of labor that you use? Well, it's just the derivative of this with respect to L. Just like marginal utility, we define the marginal product. So the marginal product of labor is just the derivative of the quantity with respect to labor. So we take the partial derivative of f with respect to its first argument, which is labor, which is what we have here. So we keep fixed the amount of capital at k bar because we can't vary that in the short run. So in the short run, it's fixed at k bar. And then we see, okay, well, if I increase the labor by a little bit, what's the per unit increase in output? Well, that's just the partial derivative of f with respect to L when we fixed k bar. And we call that the marginal product of labor. Other than the marginal product of labor, you might also be interested in the average product of labor. So what is the average output you get per unit of labor that you use? For example, if you're measuring labor in hours, you might ask how many, and if you measure output in number of widgets that you produce, how many widgets do you produce per hour of labor? Well, that would be the average product of labor. So the average product of labor is the quantity that you produce per unit of labor. So you look at the total output, given that, remember, we're in the short run, so the capital is fixed at k bar. So the total output is, if you use L units of labor, is f of L and k bar. You divide that by the total amount of labor that you use. And that gives you the average product of labor. Now, how are these two things related? Well, I'll give you a graphical explanation of how they're related. On the top panel here, I've just plotted the short-run production function. So as we vary the labor, how does quantity vary? So what we see in this picture is that as we increase labor, the total amount of output keeps increasing until we get to 20 units of labor, and then it actually starts to decrease. Now, how do we get from this picture, how do we figure out what the average product is? Well, look at this line here from the origin to B, for example. If you draw a straight line, or you could do the same thing from the origin to A. If you draw a straight line from the origin to any given point on this production function, on the curve of that production function, the slope of that straight line is going to give you the average product. Now, why is that? Well, let's look at the height here. This is the quantity produced. That's f of 10 with the fixed amount of capital. Here we've got 10 units, which is the amount of labor that we're using. What is the slope of a line? Well, to get the slope of a line, you can just look at how much it rises over how long it runs. So rise over run is the slope of a line. So if we divide f of 10 k bar by 10, well, that's just the average product of labor when labor is 10. So the slope of this line is the average product of labor when labor is equal to 10. In general, for any point on this line, for any point on this curve, you can take that point. If you want to know, okay, at this amount of labor, if I draw a straight line from the origin to the point on the curve, and I look at the slope of this line, that's going to give me the average product of labor. So what we see here then is that the average product of labor is increasing until we get to B. So if we draw these, I'll just draw a bunch of straight lines. They're getting steeper and steeper until we get to B. But then when we pass B, they're getting flatter again. So we see here that until we get to B, average product is increasing, and after we get to B, average product is decreasing. Just like the slope of these lines is increasing until we get to B, and is decreasing after we pass B. Because the slope of these lines give you exactly the average product of labor. Now, why would we expect to see an initial rise to average product of labor and then a decrease in average product of labor? We're typically going to see this because other factors might start limiting. So for example, if we have a fixed amount of capital, you could start, let's say that's the size of your factory, you could start using more labor, but as it gets more crowded in your factory, the labor is less productive. So beyond 15 units of labor, the increase in the total output is less than proportionate. So the average product starts to fall. Now what we want to do is to relate marginal product and average product. So how would we represent here the marginal product? Remember, the marginal product is the derivative, the partial derivative of f with respect to L. Since we've fixed k bar, it's just going to be the slope of the tangent to this curve. So at any given point, for example at 10, what is the marginal product of labor? It's just the slope of the tangent to this blue curve at A. What is the marginal product of labor at 15? It's the slope of the tangent to this blue curve at B. What is the marginal product of labor at 20? Again, we go to this curve, this blue curve, which is given by the production function, and we take the tangent to it, and we look at the slope of that tangent. The slope of the tangent tells us what the marginal product is. So that's graphically how we represent the marginal product. Now remember, the marginal product, just intuitively, the definition of the marginal product is what's the extra output you get per additional unit of labor. What's the average product? It's the average output you get per unit of labor. Suppose the marginal product is higher than the average product. So if I use one more unit of labor, the extra output I'm going to get is greater than average. It's greater than the average I'm getting on the previous units of labor I was using. Well, what's that going to do to the average? Well, it's going to increase the average, right? So if I add to a set of numbers a number that's bigger than average, and I take the new average, it's going to increase the average. Adding something that's above average is going to improve the average. So whenever the marginal product is greater than the average product is going to be increasing. Every additional unit of labor is more productive than average, and therefore the new average is higher. On the other hand, when the marginal product of labor is less productive than the average product, then the average product of labor is going to be decreasing. Intuitively, if the additional unit of labor is less productive than average, then the average product is going to decrease when I add one more unit of labor. So the new average is going to be lower. So what we see is that when average product and marginal product are equal to one another, average product is going to be at its highest, because to the left, marginal product is going to be higher, and so average product is increasing. To the right, average product is decreasing. So when average product and marginal product are equal to one another, remember here, the tangent and the line from the origin are exactly the same. So marginal product and average product are exactly the same at B. And that's exactly where average product is maximized. So to the left of that, marginal product is higher than average product. So average product is increasing. To the right of that, marginal product is lower than average product. So average product is decreasing. In the example that I graphed for you in the previous slide, we saw that the marginal product is decreasing eventually. So as we increase labor, eventually the marginal product starts to decrease. So there's a quote-unquote law of diminishing marginal returns, which says that as you increase the use of a given input, fixing the other inputs, the marginal product is going to diminish. So this is a law in the same sense that that we have the law of demand. It's something that we observe. It's an empirical regularity. So if a firm keeps increasing an input but doesn't change the others and has the same technology, well then the increases in the output are eventually going to become smaller. That's what the law of diminishing marginal return says. So in other words, that the marginal product is going to eventually diminish. So mathematically what that says is that as you keep increasing labor, the derivative of marginal product is going to be negative. So if I take the derivative of marginal product with respect to labor, what I'm doing is taking the derivative of, remember the marginal product is the derivative of quantity with respect to labor. Take the derivative of that with respect to labor. Well, that's the second derivative of quantity with respect to labor. So if I take the second derivative of the production function with respect to labor, in this case, that has to be negative. That's what the law of diminishing marginal return says. One important thing, you shouldn't confuse this with diminishing returns. Diminishing returns says, as you use more labor, your output's going to decrease. That's not necessarily true. There's no law of diminishing returns. There's only a law of diminishing marginal returns.